For example 8, at time t equals 0, a diver jumps from a platform diving board that is 32 feet above the water. The position of the diver is given by S of t is equal to negative 16t squared plus 16t plus 32, where S is measured in feet and t is measured in seconds. So what we have here is a position function. S of t, you can see it's in feet at any particular time t. We have two questions related to this position function. When does the diver hit the water, which is strictly speaking a pre-calculus question? And number 2, what is the diver's velocity at impact? This implies when it says velocity in any of these problems, you are assuming instantaneous velocity, which requires some calculus. At this point, it requires a limit, because that's the only way that we know how to, right now, calculate the instantaneous velocity. If a question wants average velocity, they will throw that word average in there. Okay, so for those of you who need a visual, help you understand or wrap your head around this particular situation, I've got you covered. Here we go. Let's see what's happening here. All right, well, I actually don't think that this one's accurate. How could this possibly be accurate? It says that this guy's supposed to be 32 feet above the water. Okay, well, whatever. Now, why is this in rectilinear motion? Well, because what we are assuming is that the diver is doing this. The diver is jumping upwards and then falls down, right? Due to some sort of gravity. Right, it's not strictly speaking exactly how the diver would dive, because if you dive, you're probably diving upwards and outwards, and you might follow some sort of parabolic path. But for the purposes of this problem, this is how we're assuming this motion is actually taking place, going upwards and then coming straight downwards, kind of like you throwing a ball straight upwards and it comes straight down. All right, so now let's examine the position function. S of t is equal to negative 16t squared plus 16t plus 32. Those of you who have taken physics or are currently taking physics, parts of this will probably look familiar to you. So first of all, let's look at the 32. What is the 32 referring to? Well, the 32, that was a number that was in the text here. He's 32 feet above the water. This is the diver's initial height. Okay, and then the next number, let's look at the 16, the positive 16 that's in there. How about purple? So this positive 16, what number is that? That is the initial velocity. In other words, whenever this diver starts out, they're going to jump upwards at some initial velocity before coming back down. And in the parabolic picture here, that would be once the diver reaches the peak, then that velocity is going to decrease down to 0. All right, and then the last number that's up there, let's see, this one can be blue. The negative 16 that's right in front of the t squared, where's that number coming from? Well, you in physics probably don't see it in terms of feet very often, but this negative 16 is 1/2 of the acceleration due to gravity. And that number is a negative 32 feet per second squared. So in physics, if you're working in terms of meters, that would be negative 9.8. So you might ask yourself, like, why half? Why is it half the acceleration due to gravity? Why is this initial velocity even in the position equation? And all of those answers in physics is just like, it's just an equation. We're going to write down this equation. We have a formula. We're just going to memorize it. We're going to use it. But we will see where each one of these numbers comes from and why it's in the position function. But you have to be patient, because it won't make sense until we get to integral calculus. In the meantime, we haven't even done any kind of progress on this question. All right, let's fix that. Let's answer, when does the diver hit the water? so we're looking for a time, right? So we're looking for a time, and now think about it. What's the height of the diver when they hit the water? Go away. What's the height? Remember that the S of t is some sort of height, and we're starting at 32, and that height is going to decrease until we hit the water, and the height of the diver is going to be 0. So it's basically S of I don't know what is supposed to be equal to 0 meters. So that's the setup for the first one. S of t is equal to 0, which is why the first question is basically an algebra question. So we're solving this quadratic. 0 is equal to negative 16t squared plus 16t plus 32. All right, so solving quadratic, probably going to factor this thing. Before I do, let's make it a little bit easier on ourselves by dividing by negative 16, right? Everything is divisible by 16. The negative will help me get rid of that initial negative sign there. That'll be t squared minus, no, not a 2, minus t, and then minus 2. Now it's super easy to factor. Boom, 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 boom. And, oh, before I move on, of course, this path is not the same thing as this path, of course. However, it has the same zeros, and it's easier to solve. Okay, so I know that this has got to be a t and a t. I need to multiply up to a negative 2 and add up to a negative 1, so it has to be a minus 2 and a plus 1. Set them equal to 0, and we have t is equal to a negative 1 and a positive 2. So does the diver hit the water at 2 different times? No, we have to get rid of one of these answers. Boop, boop. The negative 1 doesn't make any sense. The diver hits the water at time t equals 2 seconds. 2 seconds. I'm going to make sure that I put some units on there. So why do we have the negative 1? Well, going back to the fact that this is a parabola, and if I were to follow this parabola back over, this one would be at negative 1. It's where the other 0 would be if we started the parabola at the x-axis, and then the other one is at 2. And that's the one we care about, right? So this would be, I don't know, some sort of imaginary, if we could go back in time, negative 1 second, there you go. That's where the diver would have started his journey, or her journey. I mean, hey, come on. This is 2020. Girls can be divers too. Anyway, let's look at the second one. On number 2, what is the diver's velocity at impact? So what we're basically asking is for v of 2. And in order to answer this question, we need a limit. It's this limit right up here. We're going to take the limit of the position function, or basically the average acceleration, a change in distance over a change in time. We're going to set it up just like we did for the previous set of examples in the last objective. It is the limit as h goes to 0 of s of, we're starting at 2, right? So, okay, 2 plus h minus s of 2 all over h. There we go. So I've set up the problem. Always want to do that first, and then I can start plugging things into our function. The limit as h goes to 0, I'm going to plug 2 plus h into this position equation right here and have a negative 16 2 plus h squared plus 16 times 2 plus h plus 32. And then I want to subtract out s of 2. So ordinarily, of course, I would plug 2 into this function here and see what spits out. But I already know what is supposed to be spit out because that's what we solved for in number 1. If I were to plug 2 into this function, I'm supposed to get 0. Minus 0. There we go. All over h. So here's a question for you. What would happen if we directly substitute in our 0 for our h's? Let's see, because I'm curious. If I plug a 0 here, that would be 2 squared. 2 squared is 4. 4 times negative 16 is negative 64, right? And then on the next term, That would just be 2 in the parentheses, times 16 is 32, and then another 32 makes 64. 64 plus a negative 64 is 0. 0 over 0. Well, look at that. It's our indeterminate form. Our friend. How are we going to fix this one? Well, notice that we have things that we could expand, and you know, maybe stuff is going to cancel out for us conveniently. I have a feeling limit as h goes to 0 of, I'll expand out the perfect square here, negative 16, that'd be 4 plus 4h plus h squared. Distribute the 16, plus 32. Go ahead and subtract the 0 from it. Let's see. Do I need a calculator for that? 32 minus 0. I'm pretty sure it's 32. I'll check it at the end just to be sure, though. Okay, over h. And distribute our negative. Combine some like terms. Limits. H goes to 0. Negative 64. Negative 64 again. H minus 16 h squared. And then I can combine these up. I got 64 there plus 16h. Hey, look, something already cancels. These things cancel. These are going to combine up. That's going to make, let's see, I've got 64. I'm subtracting 16 from it. 48. I do believe negative 48. I'm running out of room very quickly. Need an extra page. These calculus problems, hopefully you have one of those 5-subject notebooks for all of these problems. Limit as h goes to 0. I'm going to have, what did we say, negative 48h, negative 16h squared over h. All right, not quite done yet because, again, if I stick in a 0, I'm still going to have a 0 over 0. I can fix that by factoring out an h from the top here. Or I can just divide h into both of these terms. My recommendation is that you actually do it as factoring because there's less of a chance of you making some sort of cancellation error. So I'm going to factor out an h, negative 48 minus 16h, all of this over h. H divided by h, pretty sure that's 1. And now we are finally ready to take this limit. Limit as h goes to 0, negative 48 minus 16h, plug a 0 up in there, negative 48. Now let's wrap our head around some sort of units, shall we? And I'm going to do that by coming back up here to the original limit that we wrote down. So remember that S of something is measured in feet. So this would have been feet minus feet, which is still feet, over, and then h is measured in seconds, right? H is just some sort of time interval, some change in time. So we have our feet per second. Boom, 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 boom. Oh, here's a follow-up question. Why this negative that's right there? Negative velocity. Does that mean that we're slowing down? No, it means specifically negative, just like in that initial picture that we were talking about, means direction is moving downwards at 48 feet per second.